Hello, welcome to the first full week of online learning for Math 1. Reminder that if you have not watched the welcome video, please do that. And if you have not read the remote learning worksheet that was, or sheet, not worksheet, but more like a syllabus, please do that. That will kind of tell you how things are working, what our schedule is, what the expectations are. You are to take notes. You are to send me a picture of them. If we have a worksheet for an assignment or practice, you need to take a photo of that and send it to me. Those are what I'm looking for photos of emailed to me. And then if we have Delta Math or Go Formative, you'll need to be working on those as well. Remember, it's about 2 to 2.5 hours worth of work a week, if that. So the reality is I'm not asking a ton. So anyway, we're going back and doing a little bit of the perimeter and area review. You kind of finished up this unit this week. So this will be the last that we do perimeter and area this week. And then next week we'll move into circles. So, okay. So you can read this obviously at the front. It says our first lesson this week is to review perimeter and area, the figures we have already discussed, which are squares, rectangles, parallelograms, and triangles. Remember, perimeter can be found the same way for all the shapes. Perimeter is the sum of the sides of the polygon. We do have some shortcuts. For instance, the sides of a square are all the same, so it's simply, its perimeter can be found by taking 4 times one side, and you can see that listed down below. Rectangles and parallelograms have 2 of the same sides, so its perimeter can be found by taking 2 times the length and 2 times the width. And then we also call those bases and heights. Remember that pretty much from this point forward, we call them bases and heights. And then the formula for triangle for perimeter simply is adding up all 3 of the external sides, the outside sides. And remember, area for each figure has a specific formula. You'll need to be familiar with each one. All right, and they're listed there for you, nice and bright colors so you can see them, all that kind of good stuff. All right, so let's go ahead and look at example number 1, and that is we need to analyze the triangle XYZ at the right. Well, the first part of this is it wants me to find the perimeter of triangle XYZ. There are a couple things that I am going to do to it first before I just go and find the perimeter, because I think there's some things we need to do. And the first thing is I'm going to look at, and I can see that this side right here, right there, is a vertical line. So that's easy to be counted. And so when I look at that and I go from the X down to the Y, I know that that is a total of 10. So that distance is 10. Well, the nice thing about that being a vertical line is I can make that side my base as well. So I know that my B is going to be equal to 10. And that's going to become important when we want to find area. That's easily be counted, right? Going from 8 down to -2. So therefore, that is simply going to be 10. And I can simply count from X all the way down to Y, 1 each, and go all the way there. Now, the other thing that I can look at when I do this is, and that is this. If that is a vertical line, then my height can be a horizontal line. So my height is actually going to come out as Z and go all the way to there, right there. And if I made that straight, and I'm going to try to make that straight. Okay, so here to here, that is going to be my height. And that is also countable. So I know when I look at that, my height, H, is going to be equal to 6. Okay, so that's going to be really come in handy for us when we go to the area part of this, because remember, if my formula for area is 1/2 base times height, I know that I already have my base and I already have my height. So I can do that one first. So I can simply find the area first. So area is going to be simply 1/2 times 10 times 6, or that's going to be simply 30 units. And remember, for any time we do area, it is going to be squared. So that's units squared. Remember, I'm going to have my calculator with me the whole time, and I have it in my hands right now, and I'm going to be using it and doing that. Okay? So let's go ahead and do the perimeter part of this. So those are two things that I've seen just by looking at the triangle, right? So what will I need though? Well, I will need x to z and y to z. And both of those are not countable because they're not a vertical or horizontal line. So I'm going to need to find the distance from x to z and from y to z. Well, I know that y is at -4, -2. I know that z is at 2, 0. And I know that x is at -4, 8. Okay, so that's where those are located on the graph. And so now I can start finding the distance. So I want to find the distance of x to z. X to z. So I'm going to find distance, and that is x to z. So when I do this, I have a -4 to 2. So -4 minus 2 squared plus, and that is 8 minus 0 squared. And -4 minus 2 is a -6 squared. 8 minus 0 is 8. So that's 8 squared. -6 squared, -6 times -6 is 36. Remember, it's going to be positive. And 8 is 64. When I do that, that comes out to nice and easy. That's a square root of 100. And we should know that the square root of 100 is 10. So I know that from x to z, x to z is 10. I'm going to mark that right on my sheet right there, and nice and easy. Okay, so now we need to find y to z. So we need to find y to z. So I'm going to do it right here down below. I'm going to find the distance from y to z. From y, -4 minus 2 squared plus -2 minus 0 squared. And -4 minus 2 is -6 squared, and -2 squared. I'm going to come up just a little bit. So d equals 36 plus 4, or d equals the square root of 40. All right, so square root of 40. Now, we're going to want this, and I want you to do, let's see, does it tell us in here, It doesn't, so let's go ahead and do decimals, okay? So let's go find to the nearest 10th. So if I put square root of 40 into my calculator, I get 6.32, so 6.3. So my perimeter there is going to be simply to add up all three external sides. So that is going to be 10 plus 10 plus 6.3. And when I get that, I get perimeter equals 26.3, and my label is going to be simply units. All right, so remember, at any time that you need to pause this, to slow down or whatnot, please pause the video, work it, do all that kind of good stuff so you can stay on track with me. Don't worry about how fast I go. You can always pause it. All right, let's go to the next one. Example 2. Now I'm going to erase these a little bit, but you had them already on there. So it gives me a little bit of room for this one if I need it. And the next one says we want to analyze the parallelogram. So we know this is a parallelogram. So part of that tells me that I know that this is congruent to this, and this is congruent to that. Now, the nice thing about on this parallelogram that we're going to call BPGN And that is, I've already given you the distances of everything that you're going to need. What I mean by that is from B to P is the square root of 40 if you can't see it. P to N is the square root of 72. And B, or sorry, that is a G. Sorry, that looked like a B. That's an 8 up there. G to E, which is going to be my height, is the square root of 32. So I'm going to kind of write that over here and say that that's a square root of 32. Okay, so that is my height. All right, we already did it. I didn't make you find the slope of the lines and all that, even though that's what we would have done in a normal everyday class. That's what we would have done. We would have had to find the slope of PN, so therefore we can know the slope of GE, and we could have done it that way, okay? At this point, I'm just giving you that distance and letting you know that GE is perpendicular to PN. All right, so if I want to find the perimeter of this, I'm going to simply take perimeter is going to be adding up all the sides. And I know that GN and BP are the same. So I know that 2 times the square root of 40 must be added to 2 times the square root of 72. Now, right now, I want you to just be doing the nearest decimal. I don't want anything other than nearest decimal for right now. And so with that, I want you to go ahead and put that into your calculator and come up with it. So you just have to put 2 square root of 40 plus 2 square root of 72. And you should come up with 29.6 units. And that's what you should get for the perimeter of this one. Now, when I look at the area of a parallelogram is going to be the base times the height. Well, we already talked about knowing that the height is going to be square root of 32. My base is PN, so that is going to be the square root of 72 times the square root of 32. Now, I want you to put that into the calculator as is, because if it comes out to be a nice whole number, great. Okay, if it needed to be to the simplest radical form, we would have, and both of these would have perfect squares as factors. We would have done that. But right now, I just want it as a nearest decimal or whole number if it comes out. And in this case, it does come out. When I put those back both into my calculator, I get 48. So my area is 48 units squared. All right. Moving on, got a couple more and then off to your practice. All right. So the next one is I want to find the area for each figure and then when needed, leave answers in simplified radical form. So these are, we're going to leave in radical form if we have radicals. All right. So as I do this, I look at this and I know that that is a triangle and I want to find the area. So I know area is going to be base times height. And when I look at this, I see that my base could be that horizontal line from A to B. And from A to B, that's a total of 14 when I count it. That graph is counting by 2s. If you didn't notice that, go ahead and look at the graph. It's going by 4s, but it's skipping a line to do it, so that graph is counting by 2s. Therefore, my base is 14. Well, I also notice that my base is that horizontal line. Then this vertical line out of point C down to the base, that straight line, is going to be my height. And in this case, that line is going to be a total distance of 4. So as I look at this, I already know what my height is. I know what my base is, so I can go ahead and plug that in. Now remember, I also need times 1/2 here. I didn't write the 1/2. I think I said it, but I didn't write it. So remember, area of a triangle is 1/2 times base times height. So when I look at this, area equals 1/2 times base times height. So 1/2 times 14 times 4. And when I put that into the calculator, I get 28 units squared since it is area. All right. Let's look at B. Okay, so when we're looking at B, I'm gonna go by, let's go to red. When I look at that, I'm pretty sure that's a parallelogram, okay? I know it's not a rectangle because they're not 90-degree angles, but I can simply count from Z to G and D to O, and those are going to be the same. It's just simple counting from Z to G and D to O. Those are the same, okay? And both Z down to D is down the same amount and over 1, and G to O is down the same as Z down to D and over 1. So I know that those have the same slope, so they're going to be parallel. Okay, so I know that Z to D is parallel to G to O. And I can simply find the slope of ZD and find the slope of GO to get that. The slope of both of those, what is that? Down, they're going by 1, so 1, 2, what is it? 1, 2, 3 over 1. So the slope is down 3 over 1 for both of those. So I know those are parallel. And then I also know that this side is congruent to this by counting. And they're also going to be parallel because they're both horizontal lines. So I know this is a parallelogram. And that really helps me because I know that opposite sides are congruent, right? So ZD and GO are congruent, and then ZG and DO are congruent. So as I do this, I'm going to simply work on that. So I'm going to erase this a little bit because the diagram's a little small, but that's okay. And the nice thing is when I count from D to O, I know that D to O is a total of 4, okay? The another nice thing about this is since that is a horizontal line, my height can be a vertical line coming out of either Z or G. And I like it coming out of G and going straight down, and that's going to be my height. Well, since DO is a horizontal line, then that line is a vertical line. That's how I was able to draw it. So when I look at this, I can count that. So my height here is going to be 3. And that's pretty easy to see. Okay, so now let's simply do the formula. So area equals base times height for a parallelogram. So area equals 4 times 3, or simply 12 units squared. All right, last example, probably the hardest one on here because we got to do a little work here. So I'm going to go ahead and erase example B because it's going to give me some space to write, and we'll get going there. Okay. Now, when I look at example Z, I want to know what kind of shape it is. I am going to assume it is a rectangle. That's my first thought. Now, I can prove it pretty easily, and that is, I can prove it by finding the slope of BY and the slope of YQ. And if I find the slope of BY and find the slope of YQ, that'll tell me if they are perpendicular because they got to have opposite reciprocal slopes. So as I do this, I'm going to do it where I can see. So the slope of BY, well, I'm going to simply count rise over run. And when I do that, I get a -6 over 4, which reduces down to a -3 over 2. And I know that that's the slope of BY. I simply counted it, okay? Now you'll notice that that graph is counting by 2's, okay? So every mark on there is 2, right? So let's do YQ. YQ, so if I count and I go, 2, 4 over 2, 4, 6, so I've got 4 over 6, or simply 2 over 3. Now the question is, are those opposite reciprocal slopes of each other? Well, the answer is yes, because opposite reciprocals means flip the fraction and opposite signs. So one's negative, one's positive, that's opposite signs. And then 2 over 3 and 3 over 2 are reciprocals of each other. So I know that this is a rectangle because this is a 90-degree angle, or that one's a 90-degree angle, then all of them are 90-degree angles. So this is going to be a rectangle, okay? So the nice thing about that is I know that this will be congruent to this, and this is congruent to this, and we can attack it from there. So let's go ahead and start finding the distance of things. So let's start writing. My point B, I'm going to write them out, is at -18, 4. My point Y is at -10, -8. And Q is at -4, -4. And those are the points that are going to allow me to find the distance from B to Y and the distance from Y to Q. I'm staying with the theme of BY and YQ. So let's go ahead and find the distance. So we got distance equals the square root of, and we're going to do B to Y. So -18 minus a -10 squared plus a 4 minus a -8 squared. Remember, two negatives make a positive. So as I do this, I should get a -8 squared plus a 12 squared. And that's going to be equal to 64 plus 144. So D is going to be equal to 208. And we've done 208 several times, simplifying radicals, and I'm going to simply give you what that is. That is going to be the square root of 16 times the square root of 13, or simply 4 square root of 13. So I know the distance of B to Y is going to be 4 square root of 13. So now I got to find the distance of Y to Q. So the distance of Y to Q. So I'm going to do it right up here. Y to Q. So this is going to be a -10 minus a -4 squared. Oh, that's too, let's not do it up there. Let's bring it down here and do it right down here a little bit. So distance equals Y to Q, -10 minus a -4 squared plus a -8 minus a -4 squared. Two negatives make positives. So this is going to be a -6 squared plus a -4 squared. I do believe, off the top of my head. So that's going to be 36 plus 16. And where is that going to give me? That's going to give me D equals, sorry, using my calculator. My brain isn't quite working for a second. So that's D equals 52. And when I look at that, I know that 52 breaks down to the square root of 4 times the square root of 13, which is 2 square root of 13. So I know that Y to Q is 2 square root of 13. All right, so as I'm doing this, and I'm going to come back up here, I need to find the area of that. So area is base times height. So area is going to be 4 square root of 13 times 2 square root of 13. Now, the thing I want you to do is put that into your calculator. If it comes out to a whole number, it is a whole number. And you should kind of see that it will. Because remember, when you do these, we're going to take the 4 times the 2 and get 8. And then we're also going to get square root of 13 times square root of 13. And remember the old analogy, the square root of a pink pig times the square root of pink pig is a pink pig. So I know that the square root of 13 times the square root of 13 is simply 13. So I know that this is 4 times 2 times 13. Or my area is simply going to be 104 units squared. Now, if you put 4 square root of 13 times 2 square root of 13 into your calculator, you would have gotten the same thing. All right. I'm going to help out just a little bit. as I said that I would do. So I'm going to erase this real quick. Remember, you can pause and go back anytime on these. And I said I would help you with answers. So I'm going to give them to you. I'm not going to do the work, but I'm going to give them to you. The first one, the perimeter, is going to end up being 37.6 units. Number two, the area is going to end up being 60 units squared. Perimeter here is going to end up being 22.2 units. And area here is going to end up being 28 units squared. And then your last three, area is going to end up being 6,250 units squared. Area equals 36 units squared, and area equals 9 units squared. All right, that's going to conclude your notes for the first section of notes for week number 1 officially. Hope you have a great week. See you for 1B here in a little bit.